Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the integration with natural log or natural logarithms. This is part 16 of the integration series, and I encourage you to check out our previous videos from part 1 to part 15. Remember also to subscribe so that you don't miss out on any of our future uploads on the integration series and any other topic. Diving into today's business, recall from video part 11, we looked at natural logarithms, and we had a situation of this nature. The integral of f prime of x over f of x dx is equal to the natural log of the modulus function of f of x plus c. Let's label this one equation 1. Make sure to check out part 11 if anything seems unclear at this point. We actually simplify everything and explain everything in great detail. And also, the integral of k times f prime of x over f of x dx is equal to k times the integral of f prime of x over f of x dx. That would give us k times the natural log of the modulus function of f of x plus c. We label this equation 2. Great. We go on to check out the first example associated with the natural logarithms. Take note. In the previous natural logarithms video, part 11, we did not have the trig functions, but now we also introduce the trig functions. So the example goes like this. Find the integral of cosine of x over 1 plus sine of x dx. And the solution. Let the denominator be equal to f of x, and we are saying that f of x is equal to 1 plus sine of x. Then f prime of x would be cosine of x from differentiation of sine. We know that when we differentiate 1, that goes to 0, and the derivative of sine x is equal to cosine of x. This would imply that the integral of cosine of x over 1 plus sine of x dx is equal to the integral of f prime of x over f of x dx. From equation 1 or formula 1, we would have the answer as the natural log of the absolute value of 1 plus sine x plus c, the constant of integration. That's how we get the answer to this problem. Let's look at example 2. So with example 2, we have find the integral of 4x minus 10 divided by x squared minus 5x plus 1 dx. So for the solution, we do the same thing. Let the denominator be f of x. So f of x is equal to x squared minus 5x plus 1. Then the f prime of x is equal to 2x minus 5. That implies that the integral of 4x minus 10 over x squared minus 5x plus 1 dx is going to be the integral of 2 times 2x minus 5. So the 2x minus 5 is being multiplied by the 2 divided by the same denominator, x squared minus 5x plus 1 dx. Now take note, we can move out the 2 or leave it the way it is because we identify something that in the numerator we have the derivative of the denominator. The only thing is that it's being multiplied by a certain constant, which is 2 in our case. So with that, then it means from equation 2, we are going to have 2, the 2 that we factored out, we take it out, we have that 2 times the natural log of the absolute value of x squared minus 5x plus 1 plus the constant of integration c. Let's look at the last example for the day. Show that the integral from 1 over 3 pi to 1 over 4 pi of sine x cosine x over 1 minus 2 cosine 2x dx is equal to minus 1 over 8 natural log of 2. The solution. Let the denominator be f of x once again. So our f of x is 1 minus 2 cosine of 2x. Then the derivative of that would be given by 4 sine 2x. Recall from the double angle identities, if we happen to have the f prime of x being equal to 4 times sine 2x, we know from the double angle that 2x, sine 2x to be precise, is equal to 2 sine x times cos x. So in this case, we just substitute for sine 2x with the 2 sine x cosine x. With that then, we are going to have 8 sine x times cosine x is our f prime of x. Then it means that our integral is going to be equal to 1 over 8 times the integral from 1 over 3 pi to 1 over 4 pi of 8 sine x cosine x. So what we have done over here is introduce an 8 and divide with an 8. So that is the same thing, but we want the derivative of the denominator to be 8 sine x cosine x. That's why we had to introduce the 8 and divide with the 8. So that is simple manipulation and getting to where we want to get to. Right, with that then, it means we can actually verify and see that that is the same as having f prime of x over f of x, that is inside the integral. And with that then, we can safely say we get 1 over 8 times the natural log of 1 minus 2 cosine 2x, keeping our limits. The next step is substituting with our limits. Of course, we start with the upper limit, subtracting with the lower limit. Then with that, we go on to simplify our work so that we have 1 over 8 times natural log of 1 minus natural log of 1 plus 2 over 2. And we know that the natural log of 1 is equal to 0, so that one goes to 0. So that what we have left inside the square parentheses or brackets is a negative natural log of 2. So with that, we factor out the negative so that our answer comes out as what was given in the question. So we have managed to show that that was that. So that is shown now. Congratulations if you've made it thus far into the video. I'll leave you with the following task. Find the integral of 2 cotangent of x dx. And remember to like, share, and subscribe so that you don't miss out on any of our future uploads. Please write in the comments how you managed to solve the problem, or write about the problems that you might have faced, including the topics that you may want us to look at into the near future. Thank you so much for watching Numbers Simplified. God loves you.